Hello, this is Simon from Reigate Maths, and this is another video for the second year content for A-level Maths. Here we're looking at the topic of differential equations, which is in the integration section of the course. This is the first of a series of videos because differential equations can get quite extended, and I wanted to make shorter videos. So the first things first is to think about what is a differential equation. Well, very simply, a differential equation is any equation that has a derivative in. So something like dy by dx equals 4x is a differential equation. Perhaps something like dA by dt equals 6 is a differential equation. Maybe x times dx by dt equals 4t is also a differential equation because they have a derivative in them. Wider, these are known as first order differential equations, but for the A-level content, that's all you have to worry about. If you're doing further maths, you go on and look at second order differential equations. So how do we solve them? Well, you've probably already solved things that look like this, these two, where we have our derivative. This matches this variable. We solve these by just basic integration. Y equals the integral of f of x. The problem arises if our derivative has a mixture of variables or is just not matching the variable that's on the bottom. Here we have to use something called separation of variables, where we move the y function over to match with the dy, the x function up, or the dx to match the x function. So what I mean by that is we end up with dividing through by gy, or g of y, to match the dy, and then the x function moves with the dx. Now we know there's integration involved, so we're just going to integrate both sides. This is going to be much easier to see what's going on when we start looking at a couple of examples. So we'll do that now. So this is our first example. We can see it's in the form our derivative equals a function of x. So separation of variables is not strictly required. So to solve this, what we do is we move the dx up and we get the integral of dy is the integral. Now let's tidy this up as we go so that we can integrate straight away. So x over x is 1. 1 over x is 1 over x dx. Now here we're integrating 1 with respect to y, which just integrates to y. This integrates to x plus ln x. And then let's not forget our integration constant. Now a couple of questions we get asked is, well, why don't we need an integration constant on both sides? It's a sensible question. Well, it's because it's a constant. We could integrate to get y plus a equals x ln x plus b. A and b are both just numbers, so we may as well collect them together into one single number. So we don't do this. This is known as a general solution to the differential equation. Okay, so this terminology is where students start to get confused because they're used to solution meaning answer. or a number or something you have calculated. They're not used to seeing an equation as being called a solution, but it is. It's general because we don't know the plus c. When we look at particular solutions in a later video, we will calculate a plus c for a given pair of coordinates. That is then a particular solution. So this is the general solution to the differential equation. Any differential equation has one general solution and has many particular solutions depending on the coordinates. So this second example is much more typical, albeit a very simple version, of what we need to do with separating the variables, because we can see that on this right hand side we have a mixture of x's and y's. So what we need to do is rearrange so the y functions are on the left and the x functions are on the right. Why is it that order? Because the dy stays where it is and the dx moves. So if you find you keep getting that wrong, do this step first. Okay, split the dx and the dy up so you know x is over here, y is over here. So now we know we need to move this y function, this y bit, here, and we're going to do that by multiplying. Okay. We integrate both. Because we're integrating with respect to y, this doesn't pose any problems. So this is just y squared over 2 equals x squared over 2. Now I'm going to put the plus c in brackets there, and I'll explain why when we're done. Because now we need to simplify and multiply through. Now I stick my plus c on the end. Don't forget, the plus c is just a name. It's just the name of a constant that is there. So there's no point writing it here and then multiplying it by 2 and calling it 2c. It's irrelevant. As long as you've got it at the end, that's fine. Now with this, we don't have to rearrange it. Okay? Unless you're told specifically to put it in a form, leaving it like this is fine, and this is actually better. Those of you who are particularly interested may well know exactly what this type of function looks like, the graph of it. You know, y squared minus x squared equals a number. It's not quite it's not a circle, because that would be plus, but it's a conic section. So this is the final answer. This is the general solution. So we don't need to worry about doing any further. Obviously, these can get more complicated, and we'll look at a more in-depth example now.